Okay, practice question, another Hardy question, question number 2, page 6. So let's get right to the question here. We're going to see that this is the other way that they can use Hardy-Weinberg. So the first example in the first video, we looked at when they give you the frequency of the allele, a single allele. Now we're going to look at when they give you the frequency of the recessive genotype. So let's go through the question. It says dominant allele R codes for the ability to roll tongue. So if you can roll your tongue, and again, let's look at some strategies on how you tackle some of these questions. This is dominant. Okay. People who are homozygous for recessive allele little r's are unable to roll their tongue. So this is recessive. If you can't roll your tongue, it's a recessive trait. In a genetics class of 145 students, so this is the total, we want to keep that, 98 students can roll their tongue and 47 cannot. Now, what we've seen, if you looked at the notes there, that when we are looking at these type of questions where they're giving us the frequency of an actual trait, disorder, disease, anything like that, it's always a genotype. It's in pairs. And what we said is that we do not ever use the dominant trait. And the reason why we don't use the dominant trait, these 98 students that can roll their tongue, it's dominant. But at this point, we don't know if these guys are P squared, which is homodom, or we don't know if they are heterodom. So because of that 98, we can't use that number 98 within our calculations because there's two potential genotypes. We need to isolate it to one genotype, and this does when we look at the recessive right here. So when we look at the recessive, 47 cannot. Now, this is the number of individuals. And if you remember in our notes, when you have a number of individuals, we can't just take that number. That's not the frequency. We have to come up with the frequency ourselves. So when they give you the number of individuals, take the number 47, that can't, over the total in the study. So that's why this was important. 145 students total. Okay? And when we come up with this, this is going to give us Q squared. Again, if it is a disease, trait, disorder, if you can't roll your tongue, yes, that is a trait. And because it's recessive, it's 2 Qs, Q squared, right? And when we figure that out, just looking at the calculator, do the calculation really quick, we can see that it comes out to 0.3241. Now there's some other numbers. The rule is generally you don't round off in the middle of a question. So you keep as many, and I'm saying keep about at least 4 decimal places. Now I know there's other ones behind that, but if we keep at least 4, it will not change our answer significantly at all. Okay, so that's what the value is, what they've given us. We had to take the individual 47 recessive individuals that can't, divide that between the total or over the total number of people in the study, and then we come up with the frequency of that recessive genotype. Okay, so that's just part of it. We haven't even actually got to the question. When we take a look at the question, it says, calculate the expectant frequency of the R and the little r allele. So what they're asking for is the dominant allele. In our formula, P represents the dominant allele, and they're asking for Q. Okay, so that's what they're actually looking for. So we're taking the frequency now, and we're finding the individual alleles, dominant and recessive, in that population. They want our answer, and I apologize for this, because it got covered up with the other one, but they want their answer in 2 decimal places. That's always important because we want to make sure after we do all this work that we record the answer correctly. So now that we have, and I'm just going to rewrite this here, Q squared equals, we said 0.3241. Like we've done before, we have to find both Q, and then using that Q, we're going to use that to go find P, like we've done in the previous examples. So if I want to find Q, this is when I'm going to have to square root my Q squared answer. So I'm going to go 0.3241. The only time we square root is when we want to find a single Q, because we have 2 of them here. So when we do that, Q equals 0.56. Now I rounded this up because they wanted that answer in 2 decimal places. So there's my 2 decimal places. That's one of the answers. Now, like I said, once we have Q, we can easily find P. And we do that using this little formula, 1 minus whatever Q is. So just to rewrite that, 1 minus, and we've already determined this to be 0.56. And P equals 0.44. 2 decimal places. And there's our 2 answers. Okay, any issues, give me an email and we'll go over it. Thanks, guys.